We're going to kick things back off with our next talk by Mangadis Tondeng, Knocking on Cloud's Door, Threat Hunting with Azure AD Reports and Azula. So with this, go ahead and turn it over to you. Thank you very much.
Thank you so much everyone for coming to the presentation. I'm Taz. I'm really happy to be here. And of course, I'll be sharing about, like the clouds using, tool that we built in-house called Azula. And then this is all about, like threat hunting in the clouds. So, like real simple disclaimer, the opinion expressed in this presentation is all mine, not my employer. And second disclaimer, this talk is not sponsored by Microsoft, nor it's a product pitch. I'm not being paid by them, but this is just my experience using Azure AD technology. And it is, just pure of that. So just real quick introduction, who am I? I'm Taz. You can find me on Twitter, Taz Manager. My GitHub account is also Taz-Manager. I'm a senior consultant on the Big Four MDRs. If you go to my LinkedIn page, you know which Big Four companies it is. So my experience mostly in detection engineering, threat hunting, threat research. Been doing quite a lot of DFIR, and of course automation, because this is like automation, like presentation. I enjoy being involved in the communities. I am one of the contributors for the DFI report. So if you know that one Twitter account that will keep telling you this is county ransomware. So I've created several articles for them. I recently also involved in OECD contributor, creating Sigma rules for the community to use. A member of the Indonesian Society for Cyber Defense, which is CDEF.id. My alma mater, Certain College, I'm also part of their cybersecurity community. And I presented in numerous international conferences, including SANS Threat Hunting last year, which is really awesome. I'm looking forward for this one. So who am I? Beside of all the security stuff, I like enjoying life. I like to do fun stuff. Last year was pretty big. Was my astrophotography get a lot of traction. So I'm gonna include the latest one that I have there. Landscape photography, fun stuff. I like good food also. Coming from Indonesia, like we have a lot of good food. If you know, like rendang, nasi goreng, like what you were talking about, it's a good food. I also enjoy, doing some memes. So who are you? Why are you here? You are either a defender or a red teamer that want to learn more about the cloud detection. You're a detection engineer. You want to build content on top of Azure AD. Of course, you can come here. Or in general, just think this presentation is going to be good. Or your boss tell you, okay, go check that presentation. So you're here now, stuck with me. Or maybe you see like, okay, knocking on the door kind of thing, Guns N' Roses, or like Azula from the Avatar, The Last Airbender. Maybe you're fans of that. Feel free coming here. Or maybe you're just lost, you don't know what to do and you cannot find your way out, but please stay here. It's gonna be awesome time, I promise. So this is what we are talking about right now. I'm gonna intro, which what I'm doing right now, understanding Azure AD, because not everyone understanding Azure AD. Introduction to the report itself, which is the logging functionality, threat hunting with it, Azula, which is the tools that we made. It's not fancy tools. It's not like machine learning, blah, blah, blah. No, it's a Python script, but it works. And lastly, I'm gonna go some closing materials. Let's understand a little bit about Azure AD. So I think most of you will know like what is traditional AD compared to Azure AD. I mean, if you have interest in this talk, you probably know what it is already. So the biggest comparison, it's traditional AD. It's in the on premises, and then cloud stuff, of course, is on the cloud, right? The Azure AD, it's actually better in a sense. It's integrated with a lot of other services. We're talking about HR systems. If you're using some other HR system, you can easily connect them using, like plugins, using applications, identity management, etc. And then everything now it's in the format of application, so it's in the cloud. So you don't really buy like boxes of medals and like, okay, this is for DNS, this is for DHCP. You don't do that anymore. It's the future pretty much. And then lastly, you can bring literally anything. Mobile device, sure. Computers, servers, yeah, we can bring that for sure. You get VMs, Kubernetes, Dockers, all those fancy new technology, yes, you can take everything there. Traditional AD, in terms of access and security, it's internal. It's in your like intranet, so that's kind of more secure? Question mark. Or is it even or maybe it's more secure than the internet, but maybe you think it's less secure. So let's talk about it, right? You have roles instead of like the domain admin, group, policy, etc. Now you have in terms of authentication, you get password, and you get additional fancy stuff like MFA, and then passwordless authentication, for example, Windows Hello, and there's some other things. Authentication options, you have more, and it's definitely different. Like you get SAML, you get OpenID, you get OAuth, you get Federation. There's also Kerberos, NTLM, and then when you heard those stuff, you're thinking about Kerberos thing, pass the hash. So all the stuff that is kind of dangerous when you're doing it in the traditional AD. Do we have it in the cloud? We'll talk about it a bit later. And then for management, you use Microsoft Graph or Azure AD Graph. Risk assessment. So if you're not familiar, what is this? This is MITRE ATT&CK framework. If you see comparing Azure AD plus Office 365 and then the Windows metrics on the right, if you see there's more stuff on the right, which means more techniques, more tactics. So technically, the risk should be less here, but if you think about it, this is of course of our simplification. And in the cloud, you can have Windows machines, you can have Linux machines. So, but from this perspective, we're just looking as itself, like the whole Azure AD authentication system compared to the Windows authentication system. So we're talking about that. So this is a great quote. It's been iterating for the last few years. I've been working in the field for a few years. They keep talking about it. Defender think in lists, attackers think in graphs. As long as this is true, attackers win, which is correct. So this is a quote from John Lambert. He was the general manager, now vice president for the Mystic, which is the threat intelligence function of the Microsoft. So let's change our mind, thinking graph too, right? So if you see the metrics for the MITRE ATT&CK, they're like connected. So if we stop the attacker from the initial access, can they do persistence? Can they do, like credential access? They never get in. Can they do that? So if we try to protect at the start, you should be worrying less on the rest of the tactics, and then you can focus more on the, like the technology base. So we can go to the Windows, you can go to the Linux machine, build protection there on the network, etc. So that's always good when you have to worry less. So some of the attack vectors that we have here, I'm going to split it before the initial access and then after the initial access. So attack vectors for the before initial access, normally from my experience as a consultant, I'm seeing a lot of negligence, a lot of misconfiguration, a lot of security protection mechanism that people don't apply. So like no MFA, legacy authentication being used, MFA user accepting random MFA requests. For example, you get like a push notification, oh, yes, although you're not like signing in. So that's not great. Don't do that. MFA compromise, of course, it's happened, like SMS hijacking, etc. And then there's alerts, there's phrase, like alert, and there's logs that's available there that's not being utilized by defenders. This is one way, this is one of the presentation ideas to let people doing that. And then of course, the brute force based factors, brute force, password spray attacks, and then the recon stuff. Because I was watching one of the presentation earlier. Unfortunately for me, there's two Microsoft presentations today, and both of them talking about Azure AD. 230% increase in password spray. So I'm gonna show you how to detect password spray and how you respond to it. And then after initial access, you probably heard like some attacks such as PHS exploit. So it's exploiting the single factor, the first factor authentication for the Azure AD. And then of course, the next one, the golden SAML exploit, Solary Gate, the big one, I think last year, if I'm not mistaken, but yeah, it's really big. It's being used like really tedious, hard to monitor because it's a combination of the ADFS and the cloud. but we put it there. And then there's some low style attack like persistence, creating accounts, like deleting logs. So it's all being done, for example, using the Azure PowerShell, using the Microsoft Graph API that I mentioned earlier. And of course, there's resource vector of the attack vectors, such as, like your VMs have vulnerability, have, TTPs, your Kubernetes, also your, like operating system, mobile phone. So it's technically in there, but we'll keep it simplified for now. Yeah. So there's a lot of protection mechanism by, by Microsoft. They got MFA. That's one of the best one. That's easy to apply, easy to use for the user. There's, a conditional access policy, like if you're combining certain signals. So if they are coming from this ASN or IP address, they cannot log in because this is malicious, or these are our IP address. So only this IP can log in. And also they might need MFA if they are not from those IPs. So that's like conditional access policy. There's attack surface reduction by using just-in-time access. You can actually block legacy authentication. As I mentioned, a lot of people still using it. Sometimes they just cannot use it, right? You can go passwordless. It might be hard, so whenever you're ready, you can do it. The security portal, which is really great actually to have like full visibility of the alerts, like how to resolve it. I'm not from Microsoft. I'm not selling stuff here, but I personally say it's great. There's risk detection that we're going to talk more about, and there's reporting, aka logs. So audit log, sign in, and then the risky users. So this is just a summary, MFA, conditional access policy, there's a machine learning and more control of the, management. And then the risk detection, we'll talk about it more in the next few slides. So introducing the Azure AD reports to you, what is it exactly? It's technically a logs that provide comprehensive view of activity in your environment. So it's the users, questionable. So you can see it from the user flagged by the risky report. This is part of their identity protection automation. There's risky sign-in. So instead of the users, they score the sign-in. Okay, so the sign-in coming from, for example, South Africa. This user never been logged in from South Africa before, so this is new. This is risky. So they're gonna alert that. And then there's audit logs, and then there's sign-in reports. The beauty of all of this thing, it's all connected. And then you can use all of them, including some other logs, such as Office 365 logs, to give a complete story of what's going on in it. So, for example, you see the risky sign-ins, and then you check the audit log. So the user successfully logged in, or the attacker successfully logged in from South Africa, right? And then you see what they are doing in it. And then you'll find, they change password, and then they add multi-factor authentication to lock out the legitimate user. So you know what's the story, you know what you need to do. I need to remove that MFA, I need to reset the password, I need to let the user know. You can check the Office 365 logs if they create persistence, etc. You can check it there. How to access Azure AD reports? I'm going to go really quick in this one because I'm not really in the deployment consulting. So you can take a look from the portal itself and the monitoring section. You can use Graph API. The best way to do it is to integrate it with SIEM. Any SIEM in this in this world is probably can load the Azure AD data. I personally use Elastic or DFE using the FileBit system. So the data presented here, it's from Elastic or DFE. So I already talked a bit on the Azure AD reports. So for the risky stuff, the risky user and the risky sign-ins, most of them will take a real time, but sometimes they'll take like offline. So there's a delay up to 24 hours. For the risky users, they are getting the data from the threat intel and also leak credentials. For the risky sign-ins, it's based on the calculation from the machine learning, based on the several conditions and signals. For the audit logs, it's just like your audit logs. It will tell you like what the user doing and also the admin's doing. All the management activities, change password, configure MFA, like remove someone from groups, etc. And then the sign-ins, of course, will collect all the sign information. Is it interactive, non-interactive? Is it fail? Is it success, MFA, or single factor? So you'll get all this information there. It can be used to track the user sign-in pattern. You can create statistic. You can create a baselining. At the end, you can use it for threat hunting, which is what we are doing right now. Some important attributes, so IP address and enrichment, so like location, is it, which ASN is it, which country, and then application and device information. You get like, okay, this is, you get user agent, this is a Mozilla, like browser, and then you get what application is being accessed. Is it, for example, Teams? Is it SharePoint? It will tell you there. And then it will tell you also like, is it phone? Is it Windows machine? Is it Linux, etc. User information, simple as usernames and then the user's name. You get also what type of the user is it, and then you get time information, which is important. So the created properties.created date time. So this is when the sign-in event come in, right? So it's based in using UTC format, and then once they process it, it will the time will call as a Azure.enqueue time. So if you see, but this time is in the local time, which for me it's in Canada Eastern. So if which is 4 hour difference. So if you see, if you change the time, so it's like 4:37 initially, but for the enqueue time, it's like 4:41. So there's 4 minutes delay. So in a sense, it's still like real time. So that's the time taken by the machine learning to, like to go through the sign-ins. MFA conditional access. So the top one, you'll see all the conditional access, like this part here. This is all the conditional access that you apply. You can have one, you can have hundreds. It will be listed there. It will be listed if they passed it or not. And then at the bottom, you can see the MFA information. Like, so what is the first factor? What is the second factor? So they use password. What kind of password? They use PTA or they use PHS. So they will tell you there. Is it successful, failed? They will tell you there. And then same thing with the second factor. Sometimes they'll tell you, okay, the sign-in coming from this mobile number, like the MFA text message to this mobile number. And then you can confirm it with the user if you're investigating something. And then we get the lastly will be, like, is the whole sign-in successful, which is the conditional access status. And then is it MFA, is it single factor, will be listed here also. Yeah, and then the risk information, of course, pretty simple. Is it low? Like, what is the aggregation level during sign-in and after it's being aggregated by the machine learning? So it can change for sure. And then, of course, is it risky or not? If it's at risk, it will show all this information. The event types, we'll go through it more, and then the details. Only certain like license have the details there, but yeah. So yeah, so what is the different even types of the risky sign-ins? There's a location-based risk. So, like a typical travel, impossible travel, the user log in from new country, and then you get IP address-based, malicious IP, anonymous IP, which is like VPN, Tor. So we'll tell you that. Anomaly based risk. So this is their machine learning doing stuff pretty much. Is the browser suspicious? There's unfamiliar properties of the sign-in. So this is new user agent. This is new application being used by the user. And then the last two here, it's from the, what do you call it? Like their office or like, like office related function. And then there's, of course, intel information. And admin also can actually confirm if a user get compromised. And there's password spray, like the one that is saying increased 230% from the last year. And then audit logs, there's multiple stuff. There's more than this full group, but mainly it's user, group, application management, and role management. So that's pretty much it. I'm not gonna go into more here. Delay. Okay, threat hunting with Azure AD reports. Let's talk about the fun stuff, the threat hunting, right? That's a little bit delay on my side. Yeah, prerequisite. So before we go to the threat hunting, we need to make sure that we have this stuff first, so you understand your organization behavior. For example, where are my employees? Are they in the United States? Do I have contractors outside? What about my vendors? Are they logging into my systems? Do we have VPN technology or not? Are we using proxy? Uh, are the user even allowed to use VPN? What about or what about, like, can you bring your own device, or is it only a device sanctioned from the, from the corporation? And then lastly, you might want to translate your policy, like your guidebook, into conditional access policy based on the, like the signals that we have in the Azure AD. So understand Azure security operations. So once someone is compromised, how do I revoke their session? How do I prompt them to reset their password? It will be also better if you understand the underlying things, the attack concepts, like how SAML, OAuth, whatever cloud lingo added here, how they work. It's better. What about ADFS? Does it add more complication when you're combining the on-premise? You need to understand that also. Of course, you need to have access to the logs using the ways that I mentioned on the slides. There's all of them is like links, so you can click it and it will take you either to the vendor website or the Microsoft website. And then SIEM is recommended for better visibility and also more processing power. So what type of attack that can be detected in the Azure AD report? So the first one will be password spray, one of the highest attack. You got legacy application, you got single factor account being sprayed with passwords. Brute force, of course, the single factor MFA brute force, and then combination of both of them. You can have like a username recon also, compromised account, like people getting phished, people data getting leaked, your company got breached, and the password getting reused by the user, which is again back to negligence. So compromised password, you can see credential stuffing attack, you can see compromised MFA, which is the user approving it. And once you're done with those attacks, you can kind of investigate the anomalies. If you see single factor in MFA environment, that's questionable. What about malicious IP address in our MIS or our TI vendors giving us some list of like IP address? Of course, you can look for it. Suspicious ASN or like organization, is it Tor, exit node, is it VPN, VPS, is it data center that you don't like maybe OVH, maybe Amazon, AWS, maybe, like some other data centers that is normally being used by attacker. And then you can check suspicious application, legacy application that is not supposed to be there. There's no way your user uses it. So you need to figure out why it's there. And if they're successful, that's questionable, right? Suspicious user agent, you have scanner, you get legacy user agent. I have the full list at the end of the slides, and then you can refer to that. And there's unusual user agent, just something that you don't really see normally. Attack detection and response. So this is maybe if I say like take 2 slides. So these slides and the next slides is probably something that you want to take from this presentation. So password spray to detect it. Also with brute force, there will be high number of fails, single factors. There's some success possible. The IP address will be unusual. It might not coming from your regular IP, maybe your corporation IP. For both of them, password spray will be multi-users normally. For the brute force, it sometimes have single user or maybe like 2 or 3 users. The major difference is on the password spray, you might see legacy or single factor application being used. For example, BAF2 AeroPC, which is Microsoft Exchange ActiveSync. So that's really like legacy application. The error codes, of course, will be the account is locked, invalid username and password, access has been blocked because of the conditional access. So because the attacker doesn't know what is your conditional access, so they just like bombard it, right? The user account disabled, they don't know if the user is disabled. So that's what's going to happen. And maybe you have success, which is kind of scary. And then the next one will be MFA brute force. They're just spamming the users with MFA requests until the user accepts the MFA request. Same thing, majority, but it will go you will see high number of failed MFA. Of course, some success possible when the user just gave up and click yes. So this is the MFA request usually coming from mobile app notifications. So like the push one. So like telling you, hey, is this you logging in from this? And then you press yes or no, right? Or a phone call. It's just bothering the user and they just accept it sometimes. Error codes, all error codes related to MFA. You can read it more detailed there. So what happened when this happened? When this occur? So one thing that you want to do, you need to quantify your attackers, collect all their IP addresses, collect their IP ranges, collect their ASNs, look for error code 0. Is it compromised or not? Is any of my user compromised? If the compromise is single factor, it means the password is already known to the attacker. So you need to review first thing you need to review the audit logs, the office logs, what are they doing inside? And then after that, you need to revoke the session, reset the password, and enable MFA when possible. For MFA, if it's compromised, you need to, of course, review the logs. The attacker might actually reset or even add or even remove and add MFA device. This happened before. I saw it with my eyes. This is kind of, like really amazing. So what do you do? Of course, you're going to revoke session, reset password, and undo all the changes that they do in the Azure AD and O365 based on the audit logs. And then depending on the company policy, well, you can actually block them, or you can report the attacker IP to, like governments, organizations for investigation, etc. And some less heavy, less, like like brute force kind of attack. So we get the compromised password. How do you know if it's compromised? It's normally single factor. MFA will be failed because it's protected by MFA. Unusual IP addresses. So the IP, it's very likely hosting, like AWS, DigitalOcean, OVH, or maybe VPN on Tor. The user agent, it's gonna stand out from the user historical data. So you see, okay, this user used like Mozilla Firefox, and suddenly you got, like Internet Explorer, and also the device, right? So they have iOS, suddenly they are logging in from Android. So compromised password and compromised MFA, which is the second one. So you get a successful single factor. It could be brute force for the MFA. It could be just the user accept it as is. It happens before. So yeah, you need to pay attention to that. Same thing with what applications being used for the MFA, mobile app notification, and phone call. IP is unusual historically. Again, it's possibly VPN, Tor, or hosting. Different user agent, as I mentioned. And yeah, and it could be single, it could be multi-user. It depends on your attacker, really. Username recon, so this is similar to the brute force pretty much, with a lot of failed single factors, but the error codes will be mainly, like invalid username or password. So yeah, same thing with the incident response. You can read this, the slides later. So triumphing at scale, when you're a large company or multinational company, triumphing can be hard. A lot of false positive. On the Azure AD risk type events, they are not perfect. So for example, for the location related, they can be like, okay, there's people traveling for business, maybe not these days, but maybe like the last few years. What a memory, right? Maybe people going for vacation, like those beaches in Mexico is really great. Like, why wouldn't people go there and check their emails occasionally, when they have to, report to their boss or whatever. External consultant on VPN, it happens. Malicious IP address, malware link IP address, so they can actually be, like misleading, like stale threat intel. Sometimes hosting data center IP address will have multiple, like users under one IP, so that could happen. Anonymous IP address, same thing. It will be like VPN. User using it for privacy, which is great for them, but we mark it as a suspicious. And then suspicious browsers, unfamiliar signing properties, could be VPN for privacy. There's also, like some user just trying new stuff, or like I'm in my family's home. I don't have my laptops. Can I borrow yours? I just want to check my email. And then like suddenly Microsoft like, oh, this is not her, which is her, but like not using the right device. So if you want to do threat hunting here, start with the risky user first. You can go through all the sign-ins if you want, but it will take a lot of resources to do that. How to reduce false positive? You have a list of known ASN or IP address range. Could be your company, could be telco company, like for example in Canada, Rogers, Telus. There's not much, so many attackers coming from those IPs. There's a risk in here for false positive, of course. And in consultant contractors IP addresses, you list all the VPN that you use, or the user that is using VPN or Tor, known country, city, like who's using legacy application, who is using single factor authentication, what application is approved, what device is approved, what user agent is approved. And then lastly, of course, you'll need to compare it with the past behavior. So introducing Azula. So if you watch Avatar, The Legend of Aang, so that's Azula on the right from the Fire Nation. So technically, okay, I'm gonna go with disclaimer first. So this tool is still in POC, and this is still in development. So modification will be required for operational use, because I use this for my organization. So my user is not the same with your user. So there's some tweaking can be done. Of course, the logic can be changed also. So Azula, when almost is not good enough. So this is pretty much like her quote. So you get the like the cycle that I'm talking: attack, detection, response, threat hunting at scale, and then reducing false positive. So they're great. We did it in like by using like human, but it's taking way too much time. So I asked the question, why don't we automate it, right? And then I automated. So this is happening. So Azula is pretty much Azure and the bracket AD, unified, lightweight, automated. So this is like automated solution to help you investigate Azure AD logs. So this is Python-based, some data analytics using Pandas, historical reference systems, reference database, enrichment. So this is relying mainly on the two logs, the sign-ins and the risky sign-ins reports. And then the audit logs can be used for investigation. So 5 components. The first one will be the enrichment components. It will check if it's a VPN, if it's stored data center using like connection to different APIs or web scraping, check the host name, geo information. So for geo information, Microsoft like the enrichment system sometimes gave the wrong data, so we like to compare it with another sources. So we have those data in there. And then we check also ASN for the logic engine. So this is, you can add it wherever you want. It's a Python code. It's like if else statement kind of thing. So if it's, for example, I want to see my North American contractor. So if they're using VPN and in North America, and then their accounts start with CONTR, like a contractor, right? So this is my North American contractor. And then you can classify that as that. Or you want to see recent scanner. So you have a list of IP address somewhere in MISP from your threat intel. And then you want to see if any of these IP address successfully logged in to the like your system. So you want to look for error code 0, and if the IP address is matching with the database that you have. You get the reference database, known one. So what is a benign ASN, what is vendor ASN, what is approved VPN provider. You get bad reference, bad user agent. So if you see Kali Linux, maybe you see Python, maybe you see like the OpenFast, you want to alert on that. There are some suspicious ASN, legacy user agent, legacy application. So both of the reference right now is using text file and sometimes inline. There's a reports engine also. Input output. So we process the data. So we technically you start with an Excel, and then you end up with an Excel with more information in it, and then your analyst can go through that pretty much and investigate more on the suspicious thing. So step by step will be prepare the CSV with the right information. I will tell you which data that we have currently. Transform the data from CSV to Pandas, apply all the like normalization, enrich the IP address information, apply logic after that, and you can compare it with the reference database, and then add the comments to help the analysts and the enrichments. And then after that, your analyst or try hunter can review it and complete the results and investigate anything that is questionable. So from the screenshot, you can see this is pretty much the logic. So you can see there's like, this is the malicious, like a known suspicious user agent. This is phone. So if for example, down here, it's a known benign telco, and you can see there's like country Canada. If the country is Canada and the telco, sorry, the ASN is this is telco, this is fine most of the time. Again, there's of course could be false positive, which can be dangerous, but this is a risk that we have accepted. This is the enrich IP, how it looked like. You get the IP, you get easy data center, VPN, Tor, location, you get the ASNs, you get the host name when available. Yeah, and then you get the sample input from here. So technically, this is just you get the information here, username, IP, etc. And then from there, you get the enriched version and you get the comments. So we'll go to the next slide, which is the demo. All right. So yeah, you get all the data here. And what you do, I'm just gonna kind of skip it a little bit. So you're gonna run the script that will be provided later, probably the next one or so. I'm still working on it, making it better. You get ASCII code, like it will process the data from the spur.us and also from the IP info. It will enrich the IP addresses, and then it will generate a new, document, Excel document, and you have the IP info information there. You'll have the spur.us information there, and then those comments that you see there, it's automatically generated by the system. So that is how this works. So, there's some of them like benign, some of them are like suspicious. So analysts can just look at it and then, okay, that's good. And then they move on. And then for the suspicious, they can erase it right away while they investigate the other stuff. So that's pretty much what's going to happen here. Yeah. And then you can see the malicious user agent, etc. And then that's pretty much it. The demo is not that great. The application, just you click it and then enrich it. That's pretty much how it is. But it helps reducing time, for example, like from 2 hours to like 30 minutes or so for our daily investigation. So there's of course blind spot from the Microsoft, from the risk model, from the threat intel information, of course, and also from our own, suppression list. So be careful with that, thread carefully. Improvement ideas, of course, you can correlate with historical data right away using CM API. You can enrichment on another stuff, for example, IP abuse DB, that will be great indication, or like from gray noise for like scanner related. You can connect with different system, for example, HR systems, check what role is the user in the organization. You can connect to audit logs, you can connect to O365 logs. You can use proper database instead of a TXT file like MongoDB or like other JSON-based database. And yeah, that's pretty much it. Thank you so much. Of course, the slide will be available. The code will be available soon. If you scan it, it will bring you to the GitHub page. I promise you it's not Rickroll. I promise you it's not malware. But the code and also the slides to my GitHub page. But the slide will be also available on the SANS page. So yeah, thank you so much.